next type of attitude scale we're going to look at is rank order scale. So let's just define rank order scale. Rank order scale is a measurement scale. And this is a measurement scale in which respondents are going to compare two or more items and rank them. When it comes to rank order scales, they can be non-comparative or comparative. So let's just define those. A non-comparative scale is a judgment that is made without a reference to another object or concept or person. So non-comparative. And a comparative scale then is going to be where where an object, a concept, or person is compared with another on a scale. Okay. So an example of a comparative scale would be like this question here, rank the following hamburgers. Here we are providing the ranking, and you can see that on the same scale, we are going to give a rank to multiple items. So we have comparing McDonald's here, Dairy Queen, Burger King, Five Guys, Wendy's. So we'd say, okay, well, which one do you like the best? Which one do you like second? Which one do you like third? And so it is a comparative scale because we are comparing these 5 items. And so we're giving them each a ranking in that same scale system. A non-comparative scale would be where we are asking about just one particular product and asking you in terms of how would you rank it? What would you rank it in terms of all of the burger joints? We haven't there provided the list of items to be in that consideration. We prefer to do comparative scales just so we know what people are thinking and comparing it to, so we know what the comparators are. With a non-comparative scale, if you say, okay, how would you rank Five Guys burgers? And you say, I rank it third. Well, we don't actually know what the other things that are in your mind that you are putting it third. What is it higher than? What is it lower than? But the downside to the comparative scale is that it assumes that we have listed all of the options you are looking for. So again, we tend to do more exploratory research first if we don't quite know what the things are people think about. So if we're going to be researching, hamburgers and people's food preferences, we first need to know what the options are. So either we're doing focus groups to see what it is people like in hamburgers and what kind of hamburger joints people even go to, or we're looking and creating some exhaustive lists of a particular location, a town, what are the different hamburger joints? Because what if that people's first preference is not on the list? Now, you can have write-ins, but the problem with write-ins, of course, is that if someone else didn't think of it, then they might also agree that it is the best, but because it wasn't an option given and they didn't happen to think about it, then they didn't put it in. So it's very difficult for the write-in options to be kind of comparative to the others because anytime we have open-ended and questions, it's more that brainstorming. You can't do that quantitative analysis to say, okay, well, here's how everyone feels about that, because they may not have thought to put it in there, even though if they were asked, they would have agreed. Now, when it comes to these rank order scales, as we talked about previously when we looked at ranking hamburgers, it could be that you super like the first choice and that the second choice you would hold your nose and eat. So there's a big difference between first place and second place. And maybe the one you chose for third place you think is equally as bad as number 2. So there's really not a big difference between 2 and 3, but a huge difference between 1 and 2. And that may be true in one person's mind, and somebody else might see 1, 2, and 3 as being really close together. So it is ordinal data because there really is no indication as to how far apart items are in people's minds. So when we have these rankings here, we treat them as ordinal data as opposed to the itemized rating scales we talked about in the previous video, which are also ordinal data, but in that case, we typically treat them as interval. All right, so we talked about rank order scales. The next one we want to look at is what is called Q sorting. Q sorting is a measurement scale. In which respondents compare multiple items and rank them using cards. So let's suppose we want to get some feedback on the features on an F-150. So we have 60 to 120 cars that all feature different aspects of the vehicle, from the different colors to the Bluetooth to heated seats and so on. Okay, so the way Q sorting works is that we would provide the respondent with the stack of cards, and they would first sort the cards into piles, features they like, features they don't like, features they're neutral about. Okay, and then what we would do is have them further sort within those piles the features they like the most and second and third and so on. And then we want to which features they dislike the most to which ones they dislike the least. So we get, of all of these cards, basically they've all been sorted in order. You can also do this in an online environment. So you can create apps where the images, you move the images up and down or plus or minus to kind of put them in order to identify characteristics that you like. What we do is we use this to identify common characteristics. Do our customers feel the same way? So is the top characteristic, the top feature of the F-150 the same for everyone? What features do people dislike the most? Maybe that's what we should be working on to address in the next version of the vehicle we create. Which features are people more neutral about? The ones they like the most are the ones that we should be advertising and promoting. The ones they dislike are the ones we should be getting rid of. And we know the neutral ones are probably not going to convert people to purchase. So we should be aware of that. So we can use this to identify what the priorities are of the people who are. So we have a sample, which hopefully represents the greater population that we care about. Then the next one we want to look at here is that we have what is called a paired comparison. And a paired comparison is a measurement scale that asks respondents to pick one of two objects in a set. So, for example, what characteristics of sun care products are more important to you? Tans evenly or tans without burning? Which is more important to you? Prevents burning or protects against burning and tanning? Which is more important to you? A good value for the money or goes on evenly? Which is more important? Not greasy or doesn't stain? And so you get two options, and each one they pick which one is more important. So this is easier for participants than the two that we just looked at before, than the Q sorting, because in that case they had to put everything in order, and easier than the rank order scale where we had to give a number for everything. So you're really only having to consider 2 options at a time. Instead of all 5 locations, I only have to consider 2 of them and how those 2 compare, as opposed to considering here 60 options, right? So in that case, the paired comparison is better than the previous 2. However, the challenge with the paired comparison is that if you are trying to consider all the different combinations, so ultimately you get to the equivalent of the Q sorting where it's fully ranked, then the problem is that question is huge. Because if you have, 10 different combinations, we have to put them all into 1 and 2, 2 and 3, 3 and 4, 1 and 3, 2 and 3, 2 and 4, every possible combination. That question becomes huge. And so for that reason as well, this paired comparison, while more popular than, say, Q sorting, although Q sorting we sometimes see in interviews and some exploratory research, the most popular is going to be this itemized rating scale. So we can get the nuances by getting how you feel from one end extreme to the other. And we could ask about different characteristics in terms of how important they are. Very important, not important. These we can analyze and are standardized, and people are used to the itemized rating scales, much more popular than, say, rank order, Q sorting, or paired comparison. For a paired comparison, if you are doing this type of analysis, you would treat it as ordinal. Okay. And it does have the benefit of bias that can be created when we put things in certain orders, because it considers all the different combinations. Okay. Another type of attitude scale is something called a constant sum scale. A constant sum scale is a measurement scale that asks respondents, oops, I forgot an S there, that asks respondents to divide a given number of points typically 100 among 2 or more attributes based on importance. So the benefit of this one compared to the paired comparison is that it is going to be much shorter. An example of a constant sum scale would be something like we see here, which is here are the characteristics of a running shoe. You have 100 points. Apply those 100 points in terms of how important these different priorities are when you're looking to buy a running shoe. So you could say, okay, 60 points to the comfortable to wear, because that's the most important, and maybe 10 for a particular sport. Brand name is not as important to me, so maybe let's make that 5. Looks cool, about the same as brand name. So now I'm at 60, 70, 80, and then maybe the rest, good value for your money. So I have an option here to show that long-lasting or made in Canada or whichever ones don't matter to me at all, because I can give zeros to them. I can show what priority things have, so you can easily see that comfortable to wear is the most important to me. And the benefit of this method over the rank order one is that I can actually show how much more important one item is versus another. Because remember, the problem we had with the rank order scale is that Five Guys could be way better than the next choice of Wendy's, or they could be basically the same and really close to each other, Five Guys slightly better, and then I would just give it, it would still end up with 1 and 2. So I can't really discern with the rank order scale how far apart the first ranked and the second ranked are in my personal opinion. But with the constant sum scale, I can, because you can see that comfortable to wear is 3 times as important to me as good value for money. I'm all about the comfort. So this gives you additional information that you don't have with the other method. Okay. So the challenge, the downside to this method, though, is that what if when someone fills this out, their numbers don't add up to 100? And we talk about cleaning our data so that we can do the analysis. The problem is we can't use just partial response from this, because if I write that this is 30, so it actually adds up to 110, and you're going to analyze these results and compare this to someone else's response to the same question. What you don't know is which one of these numbers is 10 points too high. And if we happen to know that this one was 10 points too high, where do the 10 points actually go? So the problem is that all of this information we can't use. And so we lose the response, the information from that person on this question and all of these characteristics in its entirety. So when possible, don't ask your respondents to have to do math. When you create survey questions and you want to say, how often do you do something? How often do you get it to the narrowest time period in which people can remember? So how often do you do something in a day or in a week? If you really care about how often they did something in a year, you do the math. Multiply times 52 to convert a week into a year, or 365 to convert a day into a year. You do the math. Don't require your respondents to do the math, because if they do the math and they do the math wrong, the problem is you can't use their response at all because you didn't know what it actually was meant to be. If you are doing a constant sum scale, make sure that it's 100 points, something that's easy to do the math with. Still, you're going to have problems, right? Because it's not that hard to put 10 extra points in here. And then limit the number of items, because when you get too many items, this one's got a lot of items, the chance of the math being wrong gets much bigger. If I have to take 100 and divide it up among 4 different things, that math is a bit easier than if I have to take 100 points and divide it up 10 different items, because I start to give things 5s and then the math gets more complicated. So the benefit of the constant sum scale is that additional information we don't get from others, both in terms of how far apart things are, as well as the rating, the priority. And it is much easier and quicker for people to do than, say, the Q sorting or the paired comparison, which has lots of options. But of course, the downside is math. So typically the preference of all of these different ones is more of the intent scale. You see those way more often in surveys. But if you really just need someone to put things in order of how important they are, rank order scale, if it can just be 1, 2, 3, 4, 5 in terms of importance, and that distance between doesn't matter. So we can treat it like ordinal data. If you do need the distance between the different priorities, then you're going to go with that constant sum scale. Okay, so how much more do you like something than something else? Okay. All right, let's look at the next one, which is a semantic differential scale. The semantic differential scale is a measurement scale. A measurement scale that examines the strengths and weaknesses of a concept by having respondents rank it between dichotomous pairs. So dichotomous just being there are only two options, they're the two extremes. Between you only choose one or the other. Dichotomous pairs. Dichotomous pairs. Of words or phrases. Measurement scale that examines the strengths and weaknesses of a concept by having respondents rate it between dichotomous pairs of words or phrases that could be used to describe it. So this can be useful for predicting customer behavior or the success of marketing campaigns. When you are building your semantic differential scale, never more than 7 points on your scale. So notice this looks very much like the itemized rating scale. Make it 5 or 7 point scale. And the way the semantic differential scale works is that we have the same kind of scale 1 to 5, 1 to 7, and then it's just a list of characteristics, words, or phrases where the opposite of that is what's on the other end. So, for example, we are trying to describe the local bank, and one extreme is modern, the other is old-fashioned. So you can see dichotomous, so two options, the opposite of them. Aggressive, defensive, friendly, unfriendly, well-established, not well-established, attractive exterior, unattractive exterior, reliable, unreliable, and so on. So with the semantic differential scale, we're doing a bunch of different itemized rating scales, but it's all going to be just kind of characteristics or phrases with the two extremes. And the way that it is done is that it is actually analyzed based on the pattern. So we would then look and see if we overlaid all the different responses that people had, do they have the same general pattern? Do we see that they are similar in their responses? Now, as we stated before with the itemized scale, one of the challenge becomes when you are asking multiple itemized scale is that people could say, you know what, I'm just generally happy with this company or this product, and so I'm going to go with this. Or I'm unhappy, and so I'm going to go with this. So what we see with the semantic differential scale, you'll notice that it isn't just, well, I guess in this example, what you would notice is whether or not when you build it, did you put all the positive on one side and all the negative on the other. If you put all the positive on one side and all the negative on the other, you might have people just fill it out as we said, I'm generally happy with this place, so this. Or I'm generally unhappy and put that. So that's a halo effect, the bias created by your overall impression of the company. To avoid that halo effect, you should actually mix the positive and negatives that you have on the left side. So they're all not just positive, but a mix. And then when we did our analysis, we would be looking for a similar pattern, recognizing that it's good if sometimes the answers are over here, and it's good if sometimes the answers are over here. We're looking for more of the, do we have a similar pattern among everyone, rather than comparing simply, is the average response 1 to every question? Okay, so that's dealing with that halo effect we talked about with the itemized scale. An example of a semantic differential here, indicate your impression of Five Guys burgers. And so one person could say, okay, they have low prices, their location is neutral, warm atmosphere, sure, for me, yeah, okay, limited menu, wide menu, I'm indifferent there. Fast service, okay. Low quality, high quality. So me answering this gives this pattern here. We would ask it of someone else and then see. Can I change my color here? Here we go. All right. Maybe they put here, here, here. Maybe they thought the service was slow. So in this case, so when you start to see like here where they're crisscrossing, then we have different opinions from different people. The challenge with the semantic differential scale is analysis is complicated, right? Because we're just overlaying on top of each other and looking for where there is similarity in the patterns and where there is different, as opposed to just treating these as individual rating scales where we would look for what is the average response. Is the average response 2, so higher prices, or 6, lower prices? Okay, and so for that reason, the semantic differential scales, they're not used as much as the itemized rating scale. In fact, these Likert scales we'll talk about in a moment, where again, here you have multiple features, strongly agree and strongly disagree, instead of just writing the two different words that are the two opposites. These are more popular than the semantic differential scale, mostly because we can do more complicated statistics with it by saying, okay, well, this is the average response. Here's how much variability there is. It's easier to interpret from a statistical perspective on the Likert scale than when we're trying to compare patterns in the responses. All right, before we get to that though, let's look at a stapel scale. A stapel scale is a measurement scale This is a measurement scale that requires the respondent to rate on a scale from typically +5 to -5, how closely and in what direction a descriptor fits a given concept. All right, so for example, we could say cheap prices. So if you thought that that described the product, you would pick A+, and you could go from 1 to 5. So this creates essentially a 10-point scale where we can go into the positive direction and in the negative direction. Is your website easy to navigate? If it's not easy to navigate, we pick a negative number. How negative determines how strong we feel in terms of lack of easy to navigate. So not as popular as the semantic differential scale. Notice its similarity with that semantic differential scale because it goes to those different extremes. It would be the equivalent of this being +5 that direction, -5 that direction, as we were looking at these particular ones. The choice of phrasing here can create bias. So what we use as this here, the word cheap, is that interpreted as just a low price, or is that interpreted as not value for my money? So we got to be careful in terms of the wording. That's true with all of these scales. Got to be very careful about how people interpret the phrases that are used to have a common interpretation. So the benefit of this method is that directionality as well as intensity. And so again, anyone where we are measuring not only the rating, but the intensity, how much in a particular direction, and we are seen as equal amounts. So they're the equal difference between 3 and 4 as between 2 and 3, then we would treat it as an interval scale. Okay. And we're going to discuss our last two here. In our last video, we have a Likert scale left and the purchase intent scale. So we'll end this video here and we'll cover those in the next one.